Hi guys, here we are again. Another lesson on fractions. I was going to stretch it out over 3 or 4 weeks, but I think we lost a week with waiting for the ISD to approve our plan. So I decided to group the 2 lessons last week and then put this one in for this week. So this week we're talking about equivalent fractions. Equivalent fractions means fractions that are equal. So equivalent is just a fancy word for equal. So we're looking for 2 fractions that cover the same space when they're colored in. So I'm going to show you 3 different strategies to solve this, so that way you can use the one that works for you. I have given you a fraction strips paper on your Google Slide, so you can look at this or you can print it if you want to. And it is a way to use a ruler to line fractions up, and I'll show you that in just a second. So that's one option. Another option is using little Rubik's cubes, and I'll show you those again really quick here in just a second. And then the picture representation is always a good way. So if you don't have the other 2 ways to show your fractions, then you can always draw it on a piece of paper, and that is just fine. So I'm going to start with the first worksheet, doing a couple examples off of there, and it just says it's entitled Equivalent Fractions. So it'll look like that on your Google slideshow. So we're going to do the first couple examples up here at the top. So the first one says 2/4. We talked about it in the last week's slides, how to name the fractions. So the numerator is that top number. It tells how many pieces are shaded. And the denominator is the bottom number that tells how many pieces there are altogether. Well, we have 2 different circles that are, my artistic ability is not the best, so just trust me here. They are the same size and same shape, but they're divided into different numbers of pieces. So for the first fraction, it's already done for us. There are 2 purple pieces out of 4. So 2/4 of that circle is shaded. We have to fill in the numerator for the second fraction. Remember, the numerator is how many parts are shaded. Well, in our circle over here, there is 1 piece that is shaded. So 1 out of 2 is shaded. So this would be 1/2. So 1/2 of that circle is shaded. And if you look at that, you're like, well, yeah, if I wanted the green part of the pizza, I want half of the pizza. So 1/2 of that is shaded. Well, if you look back over here and you erase the line in the middle, or you ignored that line, would those 2 circles look exactly the same? Yeah, they would. So again, I want half of the pizza. I want the purple half, or I want the green half. And if I laid the green one right on top of the purple one, they would be exactly the same. So those are equivalent or equal fractions. Another way to show that to you is to use these little Rubik's cubes. And I know they're kind of hard to see, but on the Rubik's cube you can see 1/2. So this is 1/2 of the circle, and this would be 2/4. So if we have 1/4 and 1/4, and we put them together, it equals 2/4, which is equal to 1/2. Those 2 lengths of those 2 Rubik's cubes are exactly the same length, so they are equal. This is another representation of the fraction I have on the board. 2/4, the yellow pieces, are equal to 1/2, the pink piece, because they are the same size, the same length. And as I said earlier, you can use your fraction strips paper, and I colored them on here so you could see them a little bit better. And you can see that the line for 1/2 lines up with the line for 2/4, showing that those 2 strips, that's why it's called fraction strips, those 2 strips are the exact same length. And to kind of show it and make it stand out a little bit better, I like to use a ruler. And I like to show it that way, because then you can see right where that line ends, and you can see that those 2 bars are exactly the same length. So now I'm going to pause for just a quick second, and I'm going to set the board up for the next problem. Okay, our next example that I have for you is represented with rectangles. And rectangles are much easier to draw than circles. So you can take any problem and turn it into a rectangle, and it's so much easier than circles. So always remember that. That's a helpful hint. So if you have to draw it out on a piece of paper, that's just fine. Just like I said, no big deal. But use the rectangles, because those are so much easier to draw than circles. Circles are so hard to get the pieces equal. So with rectangles, we are comparing these 2 rectangles, we are comparing these 2 fractions. So again, the first one's done for us. It says the numerator tells us that there are 2 pieces that are colored, and the denominator tells us how many pieces there are altogether, and there are 3. So 2/3 of that rectangle is okay, sorry about that. We have my granddogs here today, and so we had a little cough attack. So here's Granddog Gunner, who's having a cough attack while I was trying to teach. So sorry about that. But here we go. Let's try this again. So we have 2 fractions. We said the first one is 2/3. 2 pieces are shaded out of 3 total parts. So 2/3 of the rectangle is shaded. We need to now compare it to the pink one. So it tells us the denominator. The denominator says there are 6 pieces. 1, 2, 3, 4, 5, 6. 6 pieces altogether. And now we have to figure out the numerator. And remember, the numerator is how many pieces are shaded. So let's count them. 1, 2, 3, 4. So there are 4 out of 6 that are shaded. So 4/6 of the fraction is equal to 2/3. So again, I'm going to show you here on our fraction blocks. Mrs. Burkett just corrected me while I was paused. These are fraction blocks according to Mrs. Spitzley and Mrs. Burkett. So the first fraction is 2/3. So these 2 pieces are 2/3. 1/3 plus 1/3 equals 2/3. And we have to show how many 6ths are equal to that. So we show lengthwise there are 1, 2, 3, 4, 6 that are equal to 2/3. Well, is that what we had on our fractions on the board? Absolutely. So we know those are correct. So that is another way to show you. Here's the third way. Remember I showed you with the fraction strips. So here's our fraction strips. I colored them again so you could see them easier. And I'm going to use the ruler to show you where the end of those lines are. And again, 2/3 is the same length as 4/6. Now I want to show you a little trick, because on the next worksheet that we're going to have as an example, or the next worksheet as part of the Google slide, and the next ones I have to do examples for, there aren't any pictures. So you can get this out and use this if you want to, but I'm going to show you a trick. So just hang tight. So let's look at this problem right here. So if I wanted to go from 2/3 to 4/6 and I didn't have the pictures, there's a mathematical way we can do that. Who knew? So here we go. So if I take the 2, what do I have to multiply to the 2 to get 4? 2 times what equals 4? You got it, 2. So 2 times 2 equals 4. All right? So now, 3 times what equals 6? That's right, 2. So 3 times 2 equals 6. If you can multiply the top number and the bottom number by the same number, you can get that fraction without even looking at a picture. Let's try one together. Let me put one down here for you really quick. So if we have 3/4 and we have to figure out how many 8ths 3/4 equals, and say we didn't have a fraction strip paper and we didn't have the fraction blocks, how could we figure it out? That's right, our little trick that I just showed you. We can multiply. So you're going to go with the number that you know. For example, we know both denominators. What do we have to multiply the 4 by to get 8? So 4 times mystery number equals 8. What is that mystery number? Right now we're getting all 2's, but this is just a good way to show you. 4 times 2 equals 8. Okay, so now what did I say the trick was, or the rule was? You have to multiply the numerator and the denominator by that's right, the same number. So since we multiplied 4 times 2 to get 8, we're going to multiply 3 times 2 to get the numerator of the other fraction. So 3 times 2 equals, who's got it? Somebody has it. That's right, 6. So 3 times 2 equals 6. So 3/4 is equal to 6/8. Well, let's get out our little handy dandy fraction strip paper. And I'm going to pick one that's not colored because you can do it this way and then you don't get confused. So we're going to find 3/4. 1, 2, 3/4. So here's the end of our 3/4 line. And now we're going to look at 6/8. 1, 2, 3, 4, 5, 6. So I'm going to put my ruler right there. And are these two bars equal? Yes, they are. So 3/4 is equal to 6/8. So our little trick worked. It proved that it was right. This is the proof. Remember, I'm always asking you for the proof. This is the proof that it worked. So I'm going to pause again for a second to set up for the next activity. Okay, for this next example, we're going to compare 3 different fractions. So the first one, they've done the work for us. They've shown us. They've shown us the picture and they've shown us the fraction. 1 out of 2 pieces are shaded, so 1/2 of the fraction is shaded. Now we have to come up with how many pieces we need to color for fourths. Well, we need to make sure that the picture is exactly the same. So I think if I went across here, it's going to be this piece and this piece is going to equal 1/2. So now, when we have the rectangle divided into 4 different pieces, how many pieces did we color? We colored 2. So our fraction would be 2/4. So 1/2 equals 2/4. Now let's look at this rectangle. It's divided into 8 pieces. So if we have 8 pieces, again, I'm going to kind of like eyeball it. I'm going to run that line across there and I'm going to go right here, and here, here, and here. So now I think I have it all equal. So let's count these pieces. 1, 2, 3, 4. 4 out of 8 are shaded. So 4/8. So now let's do that little trick. Remember that little trick we learned? Okay. So if we take the 2, what do we have to multiply the 2 by to get 4? 2. That's right. So 2 times 2 equals 4. Well, 1 times 2, remember we have to multiply the top number and the bottom number by the same number. So 1 times 2 equals 2. So now we're going to go back to this first fraction again and we have to say, okay, if I want to take the 2 and get 8, what do I have to multiply the 2 by to get 8? Well, 2 times mystery number equals 8. What is that mystery number? 4. That's right. So 2 times 4 equals 8. 1 times what equals 4? Well, we know that we have to multiply the numerator and the denominator by the same number. So 1 times 4 equals 4. So this is just another sure way to show yourself that you are correct. Now let's go back to our little blocks, our fraction blocks. Okay, remember? We have 1/2. Oops. I don't have 1/2. Can you go get it for me, Taylor? Oh, I have it. It's right here. So I have 1/2. Sorry, I showed you the wrong piece. So I have 1/2. And then we have 2/4. And now we're adding 8ths. So now we have 8ths. So we have 1 out of 2 is colored. 2 out of 4 was colored. And 4 out of 8 would be colored. And all 3 of these fraction bars are the same. They're fraction blocks. They're all the same length and same size. So now let's look at our fraction strip paper. So we have 1/2 colored. We have 2/4 colored, just like we have on our board. And we have 4/8 colored. If I use the ruler, do all of those lines line up? Yes, they do. So now we know. We have proven it 3 different ways that, actually 4 if you go by the picture model, 4 different ways that we can come up with the correct answer. So just another way to do that. So now I'm going to set it up for the last activity, which is the one that I told you about is not going to have any pictures. So the very first 3 have pictures, but the rest of them don't have pictures. And that's where we're going to rely on that little trick that I taught you today to multiply or divide. Now, we haven't divided yet, have we? But I'm going to show you when you would have to do that. So give me a second to set my board up. Let me pause this right here. Okay, so here we go. For the last little bit we have to do together here. So as I said, these are examples from the paper that doesn't have pictures all the way throughout the paper. So remember that little trick I taught you today, that's going to help you solve these problems. Now I did say just before I paused it that you might have to multiply, which is what we've been doing so far, to get that strategy to solve it, to make sure that we have the right answers. But sometimes we have to divide. Why do you think there might be times we would have to divide? Well, let's kind of look at our first example. We start with 6/12, and we have to find out how many sixths equals 6/12. Do you notice the difference here? We have a big number first, a big denominator first, and then a smaller denominator. When it goes from a bigger denominator to a smaller denominator, that's when you have to divide. When it goes from a smaller denominator to a bigger denominator, then you know you have to multiply. So bigger number to smaller number, divide. Smaller number to bigger number, we multiply. So let's start with our first example. 6/12 equals how many sixths? Well, what do we have to divide 12 by to get 6? So 12 divided by mystery number equals 6. What would that number be? Well, it's been kind of through today, but it would be 2. So 12 divided by 2 equals 6. Don't always count on it being 2 because it's not always 2. It just happened to be that way for our examples. So don't get tricked by that. So 12 divided by 2 equals 6. Now what do we have to do to the top number? Remember before when we multiplied, whatever we multiply the bottom number by, we had to do the same to the top number. Same thing applies here. When we divide by 2 on the bottom, in the denominator, we have to divide by 2 in the numerator. So 6 divided by 2 equals what? If we turned it around, 2 times what equals 6? Well, 2 times 3 equals 6. So 6 divided by 2 equals 3. So 6/12 is equal to 3/6. Let's line that up on our paper over here, on our fraction strips. So we have 6/12. 1, 2, 3, 4, 5, 6. 6/12 would be there, and 3/6. Here's our row of sixes. 1, 2, 3. There's the line. 1, 2, 3, 4, 5, 6. So 3/6 do, in fact, equal 6/12. We've proven it on our fraction strips, and we've proven it up here using our multiplication or division trick that we learned today. So very good. So let's go on to the next one. 1/3 equals how many sixths? So 3 times what equals 6? Yep, 3 times 2. So 3 times 2 equals 6. So what do we have to do to the numerator in that problem? Somebody had it, I heard it. You multiply by 2. So multiply by 2. So 1 times 2 equals, we all know that one because any number multiplied by 1 is that number. So 1 times 2 is 2. So our fraction that is equal to 1/3 is 2/6. Again, let's get our fraction strip paper out. Let's line them up. So we have 1/3 is right up here. Right here's 1/3, and there's the line. And then we have 2/6. And there it is. They are completely in line with each other, and they are the same length. And you could color this again, like I said, if you wanted to. Very good. Let's do one more together. So this one is going to be a little different. So we go from 6/9. The 9 is the bigger denominator, and we want to go to a smaller denominator. So what do? Remember, are we going to multiply? Are we going to divide? Remember, when you go from a bigger number to a smaller number, we're going to divide. So 9 divided by mystery number equals 3. So 9 divided by what equals 3? What is 9 divided by what equals 3? Well, 3 times what equals 9? 3, 6, 9. 3 times 3. So 9 divided by 3 equals 3. So now, remember, if whatever we do to the denominator, we have to also do to the numerator. So 6 divided by 3 equals mystery number. So 3 times what equals 6? 3, 6, 2. So 6 divided by 3 equals 2. So we say up here by using the math trick that 6/9 is equal to 2/3. So let's check it out. Oh, we don't have ninths on here, so we can't use this. Never mind, don't use your fractions tricks on that one. So, but we did it, we proved it with our mathematical trick. So we know that it's correct because we did our multiplication division correct. So our answer would be correct. So 6/9 is equal to or equivalent to 2/3. So I know this skill is a little bit more difficult than the naming of the fractions, which that's why I gave you 2 videos last week, because I knew those would be super simple and you could get through them lickety-split. This one is a little bit more difficult. So just take your time. If you have to watch this video more than once, that's absolutely okay. And that's why we're doing it this way, so you can do that. And if even after watching the video more than once, if you are still confused, that's okay too. Just message me through class tag. We can either do a Zoom call and I can explain it to you, or I can hopefully explain it to you through class tag and I can explain it so you understand. Because I do know that this is a little bit higher level thinking and you have to do a little more work. But can you handle it? Absolutely, because I'm always wanting you to stretch your brain. So I just did that for you. I stretched your brain for you. So this week's Brain Pop video should also be about equivalent fractions. So go there and check that out and see what that's all about. And make sure you take the quiz or quizzes. You can do one or both, because I do believe next week we're going to be ordering fractions. So putting these fractions in order. And that's when our fraction strips and our fraction blocks will be coming handy for us, so we can put those fractions in order, going from the smallest to the largest, or the largest to the smallest, or comparing them, which one's bigger, which one's smaller. So that's what is coming up ahead next week. So that's what you get to look forward to. So it's been great getting to chat with you again, and I've really enjoyed our Zoom calls every Wednesday. So I will see you on Wednesday this week, and until then, stay safe and have a good time. Bye.